So graphing linear functions, section 2.3. Hopefully today is a lot of review from Algebra 1, and then if you did a coordinate geometry section in geometry, it should be review there as well. But again, we have to know how to graph. If you have your iPad pulled up and can do the graphs on your iPad, that's great. If not, you might want to get graph paper. I do have some up here. If you need some more, I can pull some more out there as well. So if you need some graph paper, come up and get some. Otherwise, if you just want to do it on your iPad and graph on the iPad, by all means, you can. Okay, but we're going to be doing a lot of the graphing of linear functions today. All right, section 2.3. A linear function. A linear function is a function that can be written in the form f of x equals or f of x equals mx plus b. Essentially, a linear function gets us a line on that root word there, line. Okay, x is the independent variable. M and b are real numbers, and again, its graph is a line. So we're going to get a line as a graph. Okay, that's the function. We're going to be dealing with everything we're graphing today should be a straight line. Okay, slope. Again, this is the formula we're going to have to remember. All right, a slope is a measure of the steepness of a line. So if you were to think of like a grade, the steepness, so that's the slope. And it's measured with x1, y1, x2, y2. Essentially, that's just the first coordinate and the second coordinate. You kind of use two coordinates to identify slope. The slope of the line known as m. M will always represent slope. For everything we're doing here today and tomorrow, m will represent slope. And again, it kind of gives us an example over here. You know, if I have two coordinates, I take my x or my y values over my x values. Okay? And I get a slope of 4 over 4 or just 1 over 1. Okay? Y-intercept is the y-coordinate of the point where a graph intersects the y-axis. So if I look at a graph, I had a coordinate plane here, and I have a line going through there. My y-intercept is that coordinate right there. No, highlighter doesn't work too well. The y-coordinate is that point right there. Or the y-intercept. It's where it's crossing that y-axis. The y-intercept is crossing the y-axis. X-intercept, the x-coordinate of the point where a graph intersects the x-axis. So again, if I have my coordinate grid there, if I throw up about the similar line, my x-intercept now it's crossing that x-axis, where it crosses the x-axis. Okay, y-intercept is crossing the y-axis, x-intercept is crossing the x-axis. And then we have slope-intercept form. This is what you'll have to know as well. Slope-intercept form is y equals mx plus b. Okay. These two things, for all you juniors getting ready to take NISA tests, they will be given to you on what would be like the NISA form. Okay. They will be used a lot. I like to say almost 1/4 of your test will be based on this section alone and probably the next section. So what we're doing today and what we're doing tomorrow will be like 1/4 of your NISA test. You'll have that many questions devoted to this. Okay, it's a big, big part of it, and you need to actually be able to identify and work them out. Okay, now again, m is the slope, b is the y-intercept. Okay, m is the slope, b is the y-intercept, and here's how it would look. Okay, so if I have y equals mx plus b, y equals negative 2x plus 4, in that y equals mx plus b form, what is my slope? Who can tell me my slope is in y equals negative 2x plus 4, John? Yeah, the slope is negative 2, which means my y-intercept then is 4. Okay, so being able to recognize that is about half of what you have to do today. Alright, so the first one here. We want to identify a linear function by using ordered pairs. And again, a linear function comes from that root word, it's a line. Alright, if I think of a line here, a line really goes up and over the same amount. It has kind of the same slope throughout. So kind of think of it like a staircase. It's going to go up and over, up and over, up and over, up and over, all the same here. So to tell whether we have ordered pairs that form a line, basically they have to change at the same rate. So if I look at my y values here, I'm going to go from 4 to 3. What am I doing in my y values? I'm subtracting 1. So from 4 to 3, I subtract 1. From 3 to 2, I subtract 1. From 2 to 1, I subtract 1. So all my y values are changing at the same rate. Okay, good. Now I check my x values. From 2 to 5, I add 3. From 5 to 8, I add 3. From 8 to 11, I add 3. Well, now I'm checking here. Are my x's and y values changing at the same rate? So I'm going -1, 3, -1, 3, -1, 3. It's like going down 1 over 3, down 1 over 3, down 1 over 3. That is a linear function. Okay, that'd be an example of a linear function. All right, and if I wanted to find the slope there, the slope would be -1/3, because that change in the y's over the change in the x. Okay, but that's a linear function because it's all changing at the same rate. Whereas number 2 here, if I look at my y values, 10 to 4, I'm subtracting 6. 4 to 2, subtracting 2. 2 to 0, subtracting 2. Well, already my y values look a little sketchy here. Let's look at the x's. -10 to -5, I'm adding 5. -5 to 0, adding 5. 0 to 5, adding 5. I'm looking at my rates, and I'm hoping they all come out to be the same, x's and y's. They are not, so that is not a linear function. Okay, because they do not change at the same rate, it is not now a linear function. Try these two. Take a couple seconds here to try these two. Alright, what do you say about number 3, Garrett? Linear function or not? Yeah, number 3 is a linear function. That is linear. What about number 4, Jack?
It is not.
Number 4 is not a linear function. As in, it does not make a line. Does anybody know what type of graph number 4 might make us, though? Nice job. It's a parabola. That's a quadratic. That's a parabola. It would look something like, if I have it correctly, something like that. That's a parabola. Nice work. Alright, so identifying linear functions, not too bad. Changing the y's, changing the x's got to be the same. Here's, hopefully coming up here shortly, here's where we're going to be focusing our time on today here. First is finding intercepts. Okay? As you look at this right here, 3x plus 6y equals 12. That would be what is called standard form. Okay, standard form simply really just means the x's and y's are on the same side. So when I say same side, I'm saying same side of the equation. Okay, x's and y's are on the same side without any fractions. So 3x plus 6y equals 12. That would be what is standard form. Okay, in order to find the x-intercept, okay, the x-intercept is where the graph crosses the x-axis. We talked about that already. To find the x-intercept, you set y equal to 0. Well, why do I set y equal to 0? Because if I look down here at my graph, anytime I cross the x-axis, y is always 0. I can cross it here, I can cross it here, I can cross it here. Every time if I look, my y values are always going to be 0. Okay? So the shortcut way here is I always show students is, yeah, you can plug y equals in, or as long as you know that, you can just basically kind of cover it up. So if I know that y has to be 0, I can just cover that part up because basically eliminating it. 3x equals 12, solve for x, my x-intercept is now 4. Okay, so I'm covering that up, solving for that part, I get x equals 4. Well, let's say I want to find the y-intercept. Well, to find the y-intercept, I'm going to simply just cover up my x. So 6y equals 12, divide by 6, I get my y-intercept is 2. Okay? Now, the key here is those are intercepts. Those are two distinct points. The biggest mistake I see students a lot of times make is they want to combine them into one. They want to say, hey, my intercept is 4, 2. Two distinctly points. Okay? This is not the coordinate. It is two distinct points, two separate points. Recognize that, okay? There are 2 points right there. And then if you had to graph it, you can just connect the dots with a line. So let's look at the next one here. Number 5. I have 2x minus 4y equals 8. I want to find my x-intercept first. So I'm going to look at this, and I want to find my x-intercept. So to find the x-intercept, my y value is technically going to be 0, or just covered. Yeah, just cover it up here. So I solve for x. My x-intercept is now 4. X-intercept is 4. I'm going to plot that point on my coordinate plane. There's 4. Now I'm going to do my y-intercept. In order to do my y-intercept, I cover up my x. So I have negative 4y equals 8. My y-intercept is at negative 2. I plot my point. I have my 2 intercepts. Now I just take my line, connect my dots, and that's graphing using intercepts. Okay. Now graphing using intercepts isn't very common, but being able to find intercepts is. Okay, so don't feel like you always have to graph using intercepts. You can, but being able to find intercepts is kind of key here. All right, number 6. Let's find my x-intercept. If I want to find my x-intercept, what am I going to cover up, Andy? Cover up the y. Solve for x, and I get my x-intercept to be what, Andy? X-intercept is 4. Good work. Well, now I want to find my y-intercept. In order to find my y-intercept, I'm going to cover up what, Phil? The x. My y-intercept is what now, Phil? Negative 3. So I plot my x-intercept was 4. My y-intercept was negative 3. I got my 2 coordinates there. Connect them with my line. Found the intercepts and I can graph. Okay. Same idea, try these next 2. Now look at number 8. Number 8 is not in what would be standard form. Okay, so your x-intercept might look a little different there. Alright, so number 7, x-intercept is 3. I agree with that.
And then the y-intercept is negative 1? No?
And the y-intercept is negative 1. I agree with that.
Okay.
So I plot the points there. X-intercept 3, y-intercept negative 1. Connect them with my line here. And there's number 7. Nice job. Number 8. Now this was kind of maybe a little tricky, or a little bit trickier here. Hopefully we can all get the y-intercept. I'll start with the y-intercept this time. What's my y-intercept, Justin? 4. Okay, that one is pretty easy. It's the x-intercept some of you might have made your mistake on. What's the x-intercept, Justin? The x-intercept is 4 as well. Now, if anybody got negative 4, I'll show you why here. So if I look at my x-intercept, you notice my x is not on the same size and it's not in standard form. So if I go to cover up my y, I'm left with 0 equals negative x plus 4. And remember, we just need to solve for x. So really it's just like saying you have to add x to the other side. So x equals 4 is where I get that at. Okay, so a little bit trickier if it's not in standard form for finding intercepts. So again, I have my intercepts there, 4 and 4. Connect them with my line. And there's using intercepts. Again, finding intercepts will be key. It's this next one that we learned to graph, that if you can graph you going this way, you will always be good. Okay, slope-intercept form. The most popular way to graph. Do you all remember hearing about slope-intercept form, if nothing else, at least in Algebra 1, hopefully? Okay. Slope-intercept form, again, comes in the form right here. Y equals mx plus b. M represents the slope. B represents the y-intercept. Okay. Again, for your juniors taking the NISA test, they will give you the form. Okay, they're not going to say, hey, m equals this and b equals this. You have to be able to identify that. But they will give you this, y equals mx plus b in slope form. All right. So on the first one here, it has it in standard form. 2y plus x equals 6. Really, slope-intercept form, you solve for y. Okay, slope-intercept form is nothing more than solve for y. Okay, you solve and set your things in terms of y here. So they show you there, they subtract the x, and then they divide it by 2. The biggest mistake students make on something like this is you have to divide all of it by 2, as in the slope and the y-intercept. A lot of times they just want to do just the constant. You have to do it to the slope as well. Do it to both. Okay, and then again, if you look at it here, y equals negative 1/2 x plus 3. Always leave your slope as a fraction, as an improper fraction as well if you have to. Don't put it as a decimal. Just kind of looks tougher when you think of rise over run as a decimal. Okay, and then when you do that, you simply just plot your points. So you always start with your y-intercept. So I start at 3 here. And then my slope is negative 1 over 2, negative denoting down direction. So I'm going to go down 1 over 2, down 1 over 2, down 1 over 2, and I just keep going and making that constant change. Kind of that staircase, so to say. All right, so number 9 here. Let's look at number 9. I want to graph y equals 3x minus 1. So I'm looking at that here. I want to find my y-intercept. Well, if I look at that, y equals 3x minus 1. That's in slope-intercept form. What's my y-intercept, Garrett? Y-intercept is negative 1. So I'm going to start off by plotting that. There's negative 1. My slope. What's my slope then, John? 3 or 3 over 1. So from my y-intercept, I'm going to go up 3 over 1, up 3 over 1. Okay. Plot my points. And now I can take my line, connect them, and I get my graph. Now, if, let's say, I run out of room on my graph, instead of going up 3 over 1, I could also go down 3, left 1. And why is that the same? Because down is a negative direction, left is a negative direction. A negative and a negative gives that still positive slope. Okay. Number 10. I have graph x plus y equals 2. I want to put it into slope-intercept form here. So to put it into slope-intercept form, I want to solve for what, Andy?
Y.
So to solve for y, I'm going to subtract what, Andy?
X.
Subtract x to both sides. Very good. Giving me y equals negative x plus 2. Again, solving for y, slope-intercept form. Now that I look at that, what's my y-intercept, Ethan? Frank? Y-intercept? Shane?
Oh, yeah. Y-intercept would be 2, and then the x would be negative 1 over 1.
There you go. So my slope is negative 1 over 1. So my y-intercept is 2. My slope, negative 1 over 1. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Plot my points. Connect them with my line. And I graph the line. Now notice, negative slopes go down. When I say down, I'm saying as I look from left to right, my slopes are going down. Positive slopes will always be going up. Yes, John?
So, if it's negative 1 over 1, then would the entire fraction be negative, or would it have to be a fraction?
I mean, the entire fraction is negative, but when you think about it associated with the numerator, as in up or down, when you do your negative, it makes it a little bit easier to denote it.
So go like down low, or is there
For the negative slope, or which one are you talking about?
like to go down low?
To go down and left, that's a negative and a negative. So, like, for example, here, if I put negative 3 over negative 1, what's that get me? A negative 3 divided by negative 1 is still a positive 3 over 1. These are the same thing. Because the negative and the negative cancel each other out, in a sense, to still get us that positive. Okay. Try these two on your own here. Take a second here. Number 11, you do have to solve for y. Okay, so if you struggle on that, try number 12 first, and then do number 11. All right, let's go through these. Let's do number 12 first. Okay, let's do number 12 first. My y-intercept for number 12 is what, Sage? 2. So I go over and plot that. My y-intercept is 2. My slope for number 12 is what, Jack?
Negative 1/2.
So I'm going to go down 1 over 2, down 1 over 2. Put my dots there, and I connect them with my line. There we go. There's number 12. Now up to number 11. Sean, did you solve for y on number 11?
Yeah.
What'd you get? Y equals?
3 over 2x minus 3.
Nice job. 3 over 2x minus 3. Now how we get that is we subtract 3x first. Okay, so subtract 3x on both sides. Now typically I always like putting it with the variable first, so it's in that y equals mx plus b form. So I rewrite it, giving me negative 2y equals negative 3x plus 6. Now I divide by negative 2, and I'm dividing everything by negative 2, which gets me then y equals 3 over 2x minus 3. Now I plot those points. My y-intercept there is what, Justin? Y-intercept's what? Yeah. What's the y-intercept? No, run number 12, bud. Or number 11, sorry. Negative 3?
Yeah.
Thanks. What's my slope then, Jarrett?
Is it 3 over 2?
3 over 2, 3 over 2. So I go up 3 over 2, up 3 over 2. Connect my dots. And there's my line for number 11. You right, Sage? Alright, number 13. Y equals negative 3. Okay, so 13 and 14 have y equals negative 3. What technically is negative 3 here? Negative 3 is my what, would you say? If it's just y equals negative 3, negative 3 is my y-intercept. Yeah, it's just my y-intercept there. Now here's where students get this and they're like, hey, what type of line do I get here? And everybody wants to say a straight line. But everything we're talking about right now is straight lines. So if I were to look at my graph, where is everything for y equals negative 3 at? Well, it's this horizontal line right here. Anytime you have y equals a number, you'll always get a horizontal line because I have no slope. Okay, that'd be like saying y equals 0x minus 3. My slope is 0 there, so I'm not rising at all. It's just a straight, flat, horizontal line at negative 3. Okay, so note that y equals gets us a horizontal line. Yeah, go for it. Take care of yourself. Number 14 now gives me x equals 2. Well, 2 is my, what would you say now? If negative 3 is my y-intercept, 2 is my x-intercept. And I want to find where everything is x equals 2. Well, that is now a vertical line going right there. So x equals 2 would get us a vertical line. Now, trick question here hopefully for us. Does anybody know what the slope is for number 14? My slope here would be undefined because it would technically be like infinity. It would be dividing by 0. It'd be, like 3 over 0. I'm going from there to there because I keep going up and up and up. I'm never going to go over. So the slope is undefined. Whereas the slope on number 13 was 0. Okay? Recognize that because on your assignment today you will have to do a couple of those. And here is your assignment.